Okay, now, the next thing we need to do is we actually need to make one small adjustment. The problem is the volume of this in millimeters cubed. And whenever the one calculates this density, it's usually done in cubic centimeters. Alright, so now how are we going to do that? Well, actually a centimeter is a tenth of a millimeter. I'm sorry, a millimeter is a tenth of a centimeter. So if you figure that means 1 centimeter has 10 millimeters, and we're looking for a centimeter cubed, it would be 10 times 10 times 10, which would be 1,000. So what we need to do now, I'm going to insert, we need to go do the volume. I'm just going to copy it because I'm lazy. Oops. We need to do the volume in centimeters cubed. All right? Again, God loves the metric system, base 10. So how are we going to do that? Well, a centimeter is 1,000 times a millimeter. A cubic centimeter is 1,000 times bigger than a cubic millimeter. So basically what we need is we need to divide this number by 1,000. So all we do is we type in equals this number backslash 1,000. That gives you the actual volume in cubic centimeters. Now the next thing I have to do, when you click on this, now you cannot see my mouse, but right now my mouse is a white cross. Your mouse should be a white cross. When you drag into the lower right-hand corner, it turns into a black cross. Alright, so if you grab the lower right-hand corner and you drag down, boom, and that will convert every one of these volumes into cubic centimeters. Beautiful. Now all we have to do is we need to calculate density. So what we're going to do to calculate density is we're going to calculate grams, which is the thickness, divided by the volume equals the cubic centimeter. Mass divided by volume equals density. So that's all I need to do. I'm going to click over. And actually, just to make this a little bit more interesting, I think what I want to do is, why not put the density right close to the coin so we can find it? There's no rule that says we have to go from left to right. So I'm going to click on here in the B column, and I'm going to go Insert, Column, and I'm going to call Density, grams per centimeter. There we go. Alright, so how do we do this? Okay, so all we have to do is we're going to say, okay, get the density equals 4.6 divided by the volume in, no, not divided by the volume there, divided by the volume here. Okay, in centimeters, not millimeters. Okay, when you hit enter, boom, that's going to give you the density of the coin. Alright, and so I'm just going to click and I'm going to drag this all the way down, and we're going to see how it looks like. Alright, and we get all these different various numbers. Now, the Morgan Silver dollars looks like, let's just for the heck of it look at the Morgan Silver dollars. It looks like the Morgan Silver dollars, pretty close. Their density seems to be right around 9.3, 9.6, 8.9. So, just for the heck of it, we're going to compare that to the density of silver. So what I'm going to do is I'm going to go, let's open up a tab, go to Google. Okay, and we're going to type in density silver. Density silver. And it looks like the density of silver is, I have to drag this over, usually it's right over here, periodic table, and if you drag, scroll down, the density is down here. Density, near room temperature is 5.49 grams per cubic centimeter, so we actually have, density is 10.9, and we actually have 10.49, and we have a density of 9.3, which is off by a little bit, but not too bad. My guess is that even the Morgan Silver dollar, which is probably fairly pure, is not completely just silver. Okay, part of the reason is because it's hard. All right, just actually the other curiosity, what about the dime? The Liberty dime. Liberty dime. Yeah, it was a little higher. Okay, so that's probably more pure silver than even the silver dollars. Alright, we're going to actually analyze this data later, but at least we now got all the density done, and then that's the next part. That's what I need you guys to do for the first step of this lab.